Good morning. Am I audible? Am I audible? Hello. Am I audible?
Yes, sir.
Yes, sir.
Screen share
Yes,
is
sir.
screen share is visible.
Yes, sir. Visible.
So, today, last class we discussed problems on the strings and ropes, and we have solved a couple of numerical problems on strings and cables, both by Lamis theorem method and the equilibrium method. So now today we shall go through some of the numerical problems wherein you have a sphere. So sphere which is subjected to the reaction forces, and also to find the unknown reactions if any. Now let us start with a single sphere problem. A sphere of weight 100 Newton is fitted in a right angle notch. So here it is a right angle box. So this angle is 90 degree. So a sphere is placed in a right angle container. The sphere weighing 100 Newton is fitted in a right angle notch as shown in figure. So if all contact surfaces are smooth, determine the reaction at contact surfaces. So here the frictional forces are not taken into consideration. Only the reaction forces are taken into consideration. Now here you have a 100 Newton sphere which is placed in a L-shaped container, and the surfaces of which is assumed to be smooth, and the sphere is having a weight of 100 Newton, and this angle is 90 degrees. So since it is a right angle container, and this side of the container makes an angle 30 degree with respect to horizontal axis, and this side of the triangle or container makes an angle 60 degree with respect to x-axis. So this is 60 plus 30, 90. So this is 90. So total is 180 degrees. Now here in this given problem, we are required to find the reaction forces. Now the sphere is making contact with the sides of the container at point A. So this is the point of contact of the one of the sides of the sphere with the sides of the container. So point A, and this side it is also making a contact with the sides of the whatever the container at point B. So these are the 2 points of contact of the sphere with respect to the surfaces of the vessel or surfaces of the container. So first you have to identify the points at which the sphere is making a contact with the sides of the container. Now this is point A and this is point B. And from the basics we know that the reaction force will be always perpendicular to the plane of the contact. Now we will have a reaction from the sides of the container to the sphere. So in this direction you will have a reaction force. That is, the upward force is the weight of the container. So because of which we will have a reaction force which acts in the opposite direction perpendicular to the plane of contact. Now let us call these 2 reaction forces as say RB and RA. Now you can see here, this is the reaction force RA acting at point A, and this is the reaction force at point B. So these 2 reaction forces are called as the opposite reaction forces. Now you can also see here, this is called as RA and this is called as RB. So these are the 2 reaction forces. Now we have to find the magnitude of these reaction forces, that is RA and RB. So now this is the given problem. So in any given concurrent force system problem, first always, especially under equilibrium of planar force system, we have to draw the corresponding free body diagram. So now you have identified the points at which The sphere makes a contact with the sides of the container, and these are the two reaction components, RA and RB. So these are the points A and B. Now we shall draw the free body diagram. Then we shall see whether the system is subjected to three concurrent forces. Then we can solve the problem by Lami's theorem method or by equilibrium method, whichever is the way you feel convenient. Now let us try to draw the free body diagram. Now these are the two reaction forces. Now in any case, we have to first select the reference axis X and Y. Now you can see here this reaction force. This reaction force is acting in the upward direction and it is directed to the first quadrant. Now you can see here, this is the reaction force from point A, which is directed towards the first quadrant. And RB is the reaction force, which is also acting upward in the direction and perpendicular to the plane of contact, and it is projected to second quadrant, RB here, correct? And the weight of the sphere obviously acts vertically downwards, 100 Newton. Now, since this is the point where you have a reaction force from point A, RA, a reaction force from point B, RB, and the weight of the sphere acting in the downward direction. Now, in order to solve the problem by Lami's theorem, we need the angle between these two forces. Now, let us go here. Now you can see here, this is the angle 90 degree, correct? This angle is 90 and this is 60. So obviously the remaining angle, RA, makes an angle 30 degree with respect to horizontal. So this is the angle required. So if you complete this triangle, so this is 90, so this is 60, so this angle is 30. So I can write here, no, 30. RA makes an angle 30 degree with respect to the horizontal axis. So similarly here, RB, correct? So this is 90 and this is 30. So obviously this angle, RB makes an angle 60 degree with respect to the horizontal axis. Now you can see here, RB makes an angle 60 degree with respect to horizontal axis. Now once you find these angles, the remaining angles comfortably you can find. So if this is 60, obviously this is 30. And if this is 30, obviously this is 60, and these angles being 90 and 90. Now, if you want to solve this problem by Lami's theorem method, so Lami's theorem is the magnitude of each force is proportional to the sine of angle between the other two forces. So 100 divided by sine 90, 100 divided by sine 90, and RA divided by sine 150, 90 plus 60, 150, and RB divided by sine 120. So by which you will get the values of RA and RB. So now the same problem can also be solved by the equilibrium method. So by which you can calculate the values of RA and RB. Now, if you apply the equilibrium method, so we know how to solve this problem by Lami's theorem method. Suppose if I want to solve this problem by equilibrium method, so first apply the condition sigma f of x is 0, so which is nothing but RA cos 30 minus RB cos 60. So you get RA in terms of RB. So sigma f of x is 0, RA cos 30 minus RB cos 60 is equal to 0, or RA is equal to RB cos 60 divided by cos 30, whatever the value is there. So next, if you want to apply the sigma f of y is equal to 0, sigma f of y is equal to 0, RA sin 30 plus RB sin 60 minus 100 is equal to 0. So since you know the value of RA in terms of RB, so if you substitute in the equation 2, the value of RA as point something of RB, then you will get the values of RA and RB. So let us now check the answers. Here RA divided by sin 120, RB divided by sin 1, RA divided by sin 150, RB divided by sin 120, and 100 divided by sin 90, and the values RB is equal to 86.60 Newton and RA is equal to 50 Newton. So you can cross-check the answers by equilibrium method by putting the condition sigma f of x is 0, That is RA cos 30 minus RA cos 60 equal to 0. And sigma f of y is 0. RA sin 30 plus RA sin 60 minus 100 is equal to 0. So these are the problems on sphere. So only thing is you have to identify the contact points where exactly the sphere is making contact with the sides of the container. So next in the subsequent problems, we'll be dealing with the 2 spheres, 3 spheres. Then we shall see. And basically, if you understand the concept, solving all this problem becomes a fun. Now you can see here, there's one more problem wherein a sphere of mass is given, the weight of the ball. So here the weight of the ball is 450 Newton. It is hung by means of a cable or a string, which makes an angle 70 degree with respect to the horizontal axis. And this sphere or ball is supported on an inclined plane, so which makes an angle 40 degree with respect to the horizontal axis. Now we have to find the tension in this string and also the reaction from the plane on the sphere, because the sphere is making a contact with the sides of the plane at this point. Say let us call this point as A. So the sphere is making a contact at this point. So then we will have a reaction force like this, which is perpendicular to the plane of contact. So let us call that reaction force as RER, because the sphere is making a contact only at one point A. So hence you have a reaction force which acts like this. And if this is 40 degree, the angle made by the reaction force with respect to horizontal is 50 degree, because it will act at right angle at the contact plane. Now, if this is 50, now you can see here, this is the reaction force, which makes an angle 50 degree with respect to horizontal. Now you have a tension force, T, because this portion of the string is subjected to two equal and opposite forces, hence it is subjected to a tension force, the angle made by which is 70 degree, and the weight of this sphere, 450 Newton, acts vertically downwards. Once you know this angle, so this is 20 and this is 40, this angle is 60, and this whole angle is 140, and the angle made by this force, tension force, and the 450 Newton force is 90 plus 160. So now you can apply the Lamis theorem, 450 divided by sine 60, R divided by sine 160, and T divided by sine 140. So thereby the answers are, the tension in the string works out to be 334.002 Newton, and the value of reaction is about 177.719 Newton. So now the same problem you can also solve it by the equilibrium method, by putting the condition sigma f of x is 0 and sigma f of y is 0. So next we shall proceed with the problems wherein you have two spheres. Now let us go through the problem. A horizontal shaft with inner clearance of 100 mm carries two spheres of radius 350 and 250 millimeters as shown in figure. Now here this is a box. It's a box container. The width of the container is 1000 millimeters or 100 centimeters, okay, or 1 meter roughly. So a horizontal shaft with inner clearance of 100 millimeters carries two spheres of radius 350 millimeters and 250 millimeters as shown in figure. The weights of these spheres are 600 and 500 Newton respectively. Find the reaction at all the point of contacts. This is a very interesting problem. So now here you have two spheres. One is Q, P, and the other one is Q. And these spheres are placed in a container of width 1000 millimeters, and the corresponding radius of these spheres are 350, and the other one is 250 millimeters. The corresponding radius are 350 and 250 respectively. So now we have to determine the contact reactions. Contact reactions means the sphere is making contact with the sides of the container at various points. First, you have to identify the points where the sphere makes the contact with the sides of the container as well as between the sphere. Now you can see here the sphere P makes a contact of the vertical face of the container at point C, and it is making a contact at the bottom face of the container at point D. And this sphere R, it is making a contact with the sides, vertical sides of the container at say point, you can call this as, so he has called this as A. And you have contact between these two. So this is the contact point between these two spheres. So we can call this contact point as point B. And this sphere is making a contact point on this side, C. So these are the 4 contact points you have. This one is called A, B, C, D. So now the required reaction forces are RA, RB, RC, and now only we have been given with the corresponding radius of the sphere. Now we have to find out the angles, some of the angles by which we can then we can comfortably draw the free body diagram. Now, here, so now this is the radius of the sphere P. This is 350 millimeters, 350 millimeters, and this is 200. So if you add 350 plus 250, it works out to be 600 millimeters. So now this is 250 millimeters and this is 350 millimeters. So if you take out 600 from 1000 millimeters, so the distance between P and R, so this PR is 400 millimeters because this is 350 and this is 250. So 1000 minus 600. So this happens to be PR is equal to 400 millimeters. Now you join the centers of these two spheres. So this is the center of the sphere P and this is the center of the sphere Q. So you join these 2 points. Okay. Now you can find out this angle. Right? So you join point Q and R. Now this becomes a triangle. So you know this side it is 400 millimeters and this angle you want, and this side you know. It is, which is nothing but the radius of these two spheres, 350 plus 250. So this is 600, this is 400. So you can find this angle theta. So cos theta is equal, you can see 600 is the opposite side and 400 is the adjacent side. So cos theta is 400 divided by 600. So hence theta is cos inverse. So this angle you will get. Now we have to find, so anyone has any doubts with respect to this? How to find this angle? Is it clear? I hope it is clear. Anyone? Hello? Hello?
Yes, sir.
Is it clear? Okay. How to
Yes,
find?
sir.
Okay. Next, we have to calculate the reaction forces. One is RA, RB, RC, and RD. Now here, RC reaction force is acting like this because it is perpendicular to the plane of contact. So the reaction from the sides of the container onto the sphere, it acts like this, RC. And here you have a force RA acting in this direction, RA. And here from the bottom you have a reaction force that is known as RD. And you will have a reaction from the sphere Q to sphere P. So this is the reaction force. It is called as RB. And this angle you have found, that is theta, whatever the value of theta. Now let us look at the free body diagram required. I think has directly solved this problem by Lamy's theorem. Now anyway, this 48.18 degree. So this theta happens to be 48.18 degree. Now, because we have to draw 2 free body diagram here, 2 free body diagram. So the one free body diagram is with respect to the sphere P. The other free body diagram with respect to sphere Q. Now first let us discuss how to draw the free body diagram of the sphere P. Now you take out this sphere outside. So if you draw a circle, so if you draw a circle and draw the x and y axis, 2 point P. So let us draw x and y axis 2 point. Now you have a reaction force RC like this, RC, RD acting in the upward direction. The weight of the sphere acts vertically downwards, that is 600 Newton. And you have a reaction from sphere Q to sphere P. So let us call this reaction as RP or RB. So this angle, 48.18 degree already you have found here. Now let us look at the free body diagram of sphere P. How does it look actually? Now you can see here the weight of the sphere acting vertically downwards. Yes, drawn the free body diagram with respect to Q. So now let us check the free body diagram with respect to P. Now this is the free body diagram of the sphere P. So the weight of the sphere acts vertically downwards. You have a reaction force RC acting like this, and you have a reaction force RD. This is RD and this is RC, and you have a reaction force RB acting in this direction and in this angle, and the weight of this sphere acts vertically downwards. Now this is the force, that is RB, which makes it is acting like this, RB, which is making an angle 48.18 degree with respect to horizontal. So now this is the free body diagram for sphere P, and if you look at this free body diagram of sphere Q, so you have a reaction force RA, the weight of the sphere acting vertically downwards, and you will have a reaction from sphere P to Q. So here RB acts in this direction. So in the case of sphere P, the RB will be acting like this. In the case of sphere Q, the RB will be acting in the other direction. Now you can see here RB. So this is RB and this angle is 48.18, and this is the weight of the sphere, and this is the reaction force RA. Now once you draw the free body diagram, then the rest becomes very simple. Either when you have a three concurrent force system, you can apply the Lami's theorem. Only thing is you have to find the angle between those two forces. Now here is given that figure, sphere Q. So this is RA and this is 48.18. So the angle between these two forces, 90 plus 48.18, so be 138.18. Yes, 138.18. And the angle between RA and RB, it is 90 plus 41 point, the remaining angle. And the angle between RA and 500 Newton forces, 90 degree. So then you can use the Lami's theorem and find out the values of RA and RB. So once you find RA and RB, you know the here, because at sphere P, you cannot apply Lami's theorem because you have four forces. One is RC, one is RD, one is RB. Anyway, RB value you know, and also the weight of the sphere acting in the downward direction. Here we can apply the equilibrium method. That is, anyway we know RB. So sigma f of x is 0. So RB minus cos 48.18. So RB value we already know it by solving the problem by Lami's theorem for sphere P. You get the value of RB. So then sigma f of x. So thereby we'll get the value of RC as 447.366 Newton. And again sigma f of y, that is RD minus 600 minus RB sine 48.18. So thereby you get the value of RD also. So that is 1,100 Newton. So now we have two spheres problem. So first thing is you have to identify the contact points of these sides of the sphere with the sides of the container. Once you find these contact points, then you have to name those contact points like A, B, C, D. Then you have to find out the contact point between the two spheres, and also be finding out the angles by using the radii and the dimensions, other dimensions. So thereby you can find this angle, and once you find these initial calculations, then you can draw the free body diagram of the corresponding two spheres. Then we can use either equilibrium method or Lamis theorem method to solve those problems. So okay. So next we shall see one more problem. Now here you have a difficult problem. So here also you have two rollers, each weighing 400 Newton, are placed in a trench as shown in figure. Assuming that contact surfaces are smooth, that means no frictional force is taken into consideration. Determine the reactions at point A, B, C, D. Now you can see here two spheres of equal weight, that is 400 Newton, are placed in such a way that which makes on an inclined plane, which makes an angle 30 degree with respect to the horizontal, and the spheres are making contact with the sides of the trench as well as between the spheres. Now identify the contact points A. So this happens to be B, and this is C, and this is B. Now here, so the reaction. So this RC, you can see here from this point we will have a reaction acting like this, and if this is 30, so the angle made by this RC with respect to the horizontal, this angle is 60 degree because it is acting perpendicular to the plane of contact. This angle is 90. So here you have a reaction force RC, and this is RA. So this angle is also same, 30 degree, 60 degree. You have a reaction like this, and you have a reaction from sphere 2 to sphere 1 like this, RB, which is parallel to this inclined plane, and you have a reaction force RD like this. Now I request you to try this problem, to draw the corresponding free body diagrams, how exactly the reaction forces acts and the angle between the reaction forces. And in the next class, we shall take up this problem again. So just try to draw the free body diagram of the two spheres. So first you can consider sphere 1. Sphere 1. Now you have a force RC, RB like this, and the angle made by this force with respect to horizontal is 30 degree. This is 30 degree. You have a, for sphere 1, RD you have RD like this, and you have a reaction force RC like this, and you'll have a reaction force RB like this. And the weight of this sphere acts vertically downwards because it's weighing about 400 Newton. So the free body diagram of sphere 1 is okay. I will continue this problem in next class. Anyway, guys, you take down this problem and try to just draw the corresponding free body diagram. So on Tuesday you have my class. So on Tuesday we shall solve some more problems on the spheres. So now we have discussed single prior problem and the double one. So in the subsequent classes we shall discuss the problems containing more than two spheres. So please mark your attendance. So I'll be ending the class. So any doubts? Anyone? Hello? Anyone? Basaraj or Ganika, are you there?
Yes, sir.
K. Amit. K.S. Rajesh Kumar.
Sir.
Rajesh Kumar, are you there?
Sir.
Call ಮಾಡ್ತಾ ಇದ್ದೀನಿ. I want to know whether you are in the class or just logged in and logged out. Okay, fine. Any?
Sir.
Are the concepts are clear? What I am teaching you? Are you following? Any problems you have in understanding the subject? Any positive feedback? Because I can improve. Okay, anyway, I'll be ending the session. So please mark your attendance in the chat box. So thank you. So have a nice day. Stay safe.